see this, guys, when I do this. You guys see this? Even though he messed the board up? Looks like it messed the computer up. Okay. Find the zeros. Find the zeros. Now, if it's worded like that, please tell me before I show you the example there, and we'll try to find the zeros. And we'll be, oh no, that's even hard for me to see. Maybe it's a different marker I should be using. Okay, find the zeros. I will name a function for you. And if I say find the zeros, that means all the zeros, which might mean from last Wednesday, what could be involved here? I's. Okay, so I'm looking for all the zeros possible, and there may be some imaginaries involved. I'm trying to use the black marker, guys, to see if this works any better. He's really messed this board up. Is that better? I think the purple? Okay. Now, I'm going to start out with this one. X to the 6 is the function. X to the 6, subtract 9x cubed plus 8. And if it looks strange like that one, I'll have on the side on the exam, so you will know what I'm looking for. It might be helpful to let you represent something and rewrite this in a form that you can deal with fairly easily. Guys, look at it and tell me what you might let you be based on what you see. Usually it's that middle term there, in this case the x cubed term. And the reason is this first term, x to the 6th, could be written as, if I wish, x to the 6th could be written as x cubed squared. That's not x to the 5th, that's x to the 6th from a property of exponents. So if I do that, guys, this becomes u squared. The middle term, 9u plus 8. Now, I'm asked to solve that. Now you're across the street at the middle school. So you've changed this. I don't think those middle school kids across the street could do this one. I might be someone that could do it. But they could do this one. I have 8th grade, 9th grade over there. They could do that one. I'm going to factor this one as a quadratic. And if I do factor, do not let me make a mistake. Looks like it's u minus 8, u minus 1. You guys agree? Split this up. I'm looking at 8 and u is equal to 1 when I solve those. You're going to have one of these on the test. A couple of these maybe. And what was u representing at this point? It says x cubed is equal to 8 and x cubed is equal to 1. Now I think this connects with last Wednesday, what we were doing. Now, I'm looking for 6 zeros. They call them zeros of this function. 6 answers. Guys, this one right here, x cubed is equal to 8. One obvious answer is x could be what?
1.
Not 1, no, 2. Over here is 1. Is that true? Now I have 4 remaining zeros that are missing. Now that was the issue last Wednesday. I've got 4 missing. So right now at this point, let me do this. I have 2, I have 1, and we're missing 4. Now, can someone connect with me? I know it's been a long time since I've seen you. Connect back to Wednesday of last week and tell me, what did we try in an attempt to find the remaining 4 zeros? Who recalls?
Move the 8 to the other side.
Move the 8 over, and guys, I don't know whether you, I hope you can see this. If not, let me know. Move the 8 over and make it look like that, x cubed minus 8, which is good. Why do that? I think it takes the form of something we worked with last Wednesday. It takes the form of a cubed subtract b cubed. Okay, does everyone in class can see this, I hope? Okay. Now, I'm putting it up here so you can see it. If it's a cubed minus b cubed, without me placing the formula on the test, you should know that's a difference of 2 cubes. Can anyone tell me what the formula is? Okay, go for it. All right, don't scare me. You just tell me the
8
standard
minus-
formula first.
8 minus
A subtract B. Tell me more.
A squared
A squared.
plus AB
Love it.
plus B squared.
There's your formula. For the difference of two cubes, which is the form of. Now, with that formula that was given to me, guys, here we go. I'm going to go over on the side here so you guys can see it. Not, please let me know. X cubed minus 8 equal to 0. Takes the form of A cubed minus B cubed. Where, help me out here. Could I write this as, if it's A cubed minus B cubed, guys, is the X acting as the A? Now be careful. What's acting as the B? 2. This can be written as 2 cubed. That's 8. So now I know what the A is. I know the B, A is X, and the B is acting as a 2. If I replace that in that red formula, this looks like this. A subtract 2, A squared plus 2A plus 4, 2 squared. Let me step back, would you guys agree? Yes or no? If I use this formula. Yes or no?
Yes.
Okay. Then that's set equal to 0. You are now ready to split this up and write this out, and I'm going to put an X in here, guys. X subtract 2 equal to 0. And X squared plus what was that? 2X plus 4 is equal to 0. Yes or no? Is that what we're doing? We're back into X's here. You're going to end up with X is equal to 2 here, which I think we placed that already. But now we have something different. We also have an X squared plus 2X plus 4, which came from this. Is that true? And guys, I can solve this by quadratic formula. I'll tell you ahead of time to save some time. It's not going to factor. So by quadratic formula, it's going to look like this. I got to be careful not to make a mistake here. That's 4, subtract 4 times 1 times 4 all over 2. Or this is negative 2 plus minus. Now, can anyone tell me what underneath that square root, what is that value underneath here? Be very careful. Negative 12. 4 subtract 16. That's a negative 12. All over 2. And you end up with negative 2 plus minus, and here we go. Square root negative 12 in the real numbers does not exist. If I say find all zeros, that means find all of them, even the so-called complex. What can I do with square root negative 12? Could I bring the I in?
Yeah.
Okay, this could be written as, now here goes. So I will know what I'm doing here. And that square root negative 1 is known as, denoted with an I. Square root 12, guys, not perfect, but I can deal with it. What would break that down? 4 times 3?
Yeah.
So 2 radical 3. And therefore I'm going to write this now as 2i, looks better in this form, 2i radical 3 still over 2. And can I reduce this down? I certainly can. Divide all those by 2. And you end up with, if there's no mistake at this point, those answers. Yes or no? Okay, now that tells me at this point I have 2 more answers up here. I have a negative 1 plus I radical 3. And I have a negative 1 minus I radical 3. There's 2 more answers. Now to save me a little time, we have 2 more zeros to find. There should be 6. Does anyone have an idea what I can do to find the last 2 zeros? Answers.
Do the same thing to the x cubed minus 1.
Okay, I'm looking at something here. You're telling me right here on x cubed is equal to 1. Could I rewrite that and put it in red? Could I rewrite that and say, Professor, you could write this as x cubed subtract 1. equals 0. Is that true? And does this now take the form of a cubed subtract b cubed? Yes or no? Now, is there also a formula for, and my student who helped me out last with the other formula, was there a formula for a cubed minus b cubed? In fact, it's the same formula. It's not a plus in this case. I'm gonna use the same formula. Guys, if I apply the same formula up there on x cubed minus 1, please tell me right quickly, I don't want to do it too quickly, would I end up with x subtract 1, x squared plus x plus 1, yes or no? If I apply the difference of cubes formula, I see above me, on this, would it give me this? Yes or no?
Yes.
Ooh, I see it's a Monday, it's been raining a little bit outside, it's cold today.
Yes.
It does? Okay. And if I split this up, guys, and I know I'm running out of board space here, I see a 1 coming out, well, we had 1 already. And then I have on the side here, let me bring it over here so you guys can see it, I have x squared plus x, looks like plus 4, to deal with. Plus 1, not 4, plus 1. You guys agree? Right here? Right over here so you can see it? Right here. From the formula. Yes? No?
Yes.
X squared plus x plus 1. If I use quadratic formula on this, guys, here goes. X is equal to negative 1 plus minus square roots. 1 subtract 4 times 1 times 1. What a mess. All over 2. That's quadratic formula applied to that. If we have no mistake, let's hope we don't have a mistake. So this is x is equal to negative 1 plus minus. Guys, underneath that square root is what?
Negative 3.
Negative 3. And the best I can do here is negative 1 plus minus. What's a good way to express now square root negative 3? I radical 3. And that's still over 2. I'm going to step back and look at it, make sure, guys, everything's done correct. Look at the board space it took me. I just do this one problem. Now, what is it? Well, if I separate them, one answer is, if there's no mistake, negative 1 plus I radical 3 all over 2. And the other answer is negative 1 minus I radical 3 all over 2. Do we now have 6 zeros? Do we finally have 6 zeros? With the help of some cube formulas? Now, by the way, I notice this is not the only one I'm doing today. Just in case, was there also a sum of 2 cubes formula? And we saw that last week too, didn't we? So you may have to apply that. It all depends on what you have to work with. Guys, how's it look? Now, you see one like that on the exam on Wednesday. You saw how much time it took me? That's going to be a little chunk of time there. Just to do this one, if you see one like this. Any concern here? Yes, go ahead.
Can we skip the part where we say, can I just go in the shower?
Well, tell me first.
So we say x squared equals 8, then x equals 2. But can
Well,
we
x cubed equals 8.
Yeah. Can we skip this part because we're gonna find out that x equals 2 and 1, but we can do the next steps. Does that?
You're saying we're going to do these 2,
Yeah.
and then you're going to do these other 4?
Yeah. We will find all of them if we just say.
Oh, I got you. You're saying, Professor, could I have just moved this over, wrote this in the, I got you, a cubed minus b cubed to begin with, and not have said this obvious answer. I do see this obvious 2 here. But say, Professor, why was I even do that? I went directly to that formula. Would that repeat that 2 that I had to begin with? Absolutely. You could apply the formula immediately and got those answers. Good question. Guys, anything else? Let's hope there's not a sign wrong or whatever there. Look at the board space it took me to do this. Okay, I'm gonna leave it. Now keep in mind, yours on the exam on Wednesday may have a cubed plus b cubed involved. And I gave you a formula also for that, so be on the alert. Now, I'm gonna leave this, but the interesting thing would be, suppose I had given you these 4 answers first. Suppose I was nice enough to say, here are the 4 answers. Oh, Professor, how nice, you've already solved it for me. And you've already given me the 6 answers, the 4 answers for the eyes, and then the other 2. You give me all 6 answers. Suppose I give you all 6 answers. And guess what I'd be asking you to find? Where'd they come from? You have to go back and find this. If I'm nice enough to give the answers to you, can you be clever enough to go backwards and say, oh, he wants to know the function those 6 zeros came from? That x to the 6 business out there. I'm not going to do that unless it's an extra credit. It would require a little bit of time. That could be done. Guys, I'm done with that. How's it look? So far, so good? Let you be something. We tried some of those also last Wednesday. This is me doing a little recap here before I jump in where I should be here. Oh my goodness. Part B, I almost left it out. Let's call this h of x. Gotta do this one. And it looks like this. Solve, find x, find the zeros, and you have this. This is one I had planned to place on your test. That's why I want to replace it now. But, and for a little hint, I will have written on the test, this might help if you decide to do this. Can anyone tell me what? You might be here. Thank you. I give you partial credit for me show me that. Now why? Look at this, it's strange. You see that x in the first term? That x in the first term could be written as, if I wish, and I wish, it could be written like that. Right? And then with that u equal square root x, make my replacement, this becomes 3u squared, subtract 13u, subtract 10, is equal to 0. Now you're back in middle school. That's what the middle school kids can do. I'm going to try to factor this. It may factor. I hope it does. You got here goes 3u. I think it should be a minus 5 here. Save me a little time. Plus 2. Let me step back and look at it. Oh, it is. Split this up. You know the routine by now. And this. In this case, guys, I think you'll end up with u is equal to a negative 2/3. Watch my math here, please. And u is equal to 5. Now, are we finished? No, what was u representing? Well, so, yeah, u was representing what? Square root x, was it? So I need to go back and say, wait, hold on. This says square root x is equal to a negative 2/3. And square root x is equal to 5. You guys with me at 4 o'clock, we saw something like this at 4 o'clock, I think. Is that true? Now, please tell me. Let me jump to the one on the right first. This one says the square root of some number is 5. I think we all know it's 25, Professor. If I don't see it right quickly, I could square both sides to solve it and get 25 in no time. Now, you guys were with me at 4 o'clock. Can I do the same thing on the other side? Go ahead and square both sides, or is there an issue? There's an issue there. It says square root x is equal to what? A negative 2/3? You never have a square root equal to a negative. So this is undefined to begin with. I can't deal with it. Reject it. So after all that work, you have one answer, 25. With the original problem. Yes?
How many answers should we do?
Beautiful. Beautiful, beautiful, beautiful. You really can't tell on this one. You say, Professor, does it mean maybe the highest exponent, the exponent understood to be a 1 here, and the exponent understood to be what, 1/2 here? So maybe since that one is bigger, maybe just one answer, and we did just get one. It's difficult with a fractional exponent to determine. So watch out for that. By the way, guys, I will check this right quickly. Let me just do it real quick before I take a question. If I put 25 in, 3 times 25 is 75. I'm checking the answer. If I put a 25 here for the x, square root of 25 is a 5. 5 times 13 is 65. Then subtract 10 on the end. Well, all that can be a 0. Which says it checks. 25 will check. Okay, I saw a hand going up. Yes?
The question says find all the complex zeros, but that not.
Ah,
that
beautiful.
not-
Oh, that just came at 4 o'clock. Beautiful, beautiful question. Beautiful question. Because a professor, I thought we could use complex or i's. And the answer looks like this might be appropriate to have an I in there. Be careful, it does not say this. If it said that up there, you can use an I. So guys, look at this. This is different than this. Down here, reject immediately. There's not when everything works like that. If it had done, or if it had looked like this, then there's an I there. Glad she asked. Guys, anything else? Now, I think that takes me back to, took me maybe 30 minutes. Jeez. But took me back to Wednesday. Were we doing this on Wednesday? Of course we were. Part 1, let's call that part 1. Part 2, I have this. I thought I'd bring it in and show you what I did. Beautiful. You're going to have a transformation problem. So I looked through and I thought, wait, now hold on. Part 2, sketch using transformations. Now get ready. And based on what I remember the class doing when we did those few transformation problems right last week, you guys were doing it. In fact, Ignacio, I think you came up to the board and showed us something on transformations in class. Billy, I think you came up to the board and was doing something with us when I did this to begin with. But here's what it comes down to. Sketch this function, guys, it's called f of x. And you're going to use transformation. Watch, watch, oh watch. Careful. I'm going to sketch the graph of that. And I will do it through transformations. Get ready. And I'm going to ask you to write out, for partial credit on the test, write out each transformation in words. Is it a shift to the left? Is it a shift to the right? Is it a reflection across the x-axis? Is it a reflection across the y-axis? I think I've got almost everything involved in this one. So this is a good example to look at. Now, as I look at it, and based on me realizing what a good class I have to work with, I've been bragging on you guys already. I have enough colors here. Let's see how many transformations are involved first. Guys, can someone tell me, and you want to write this out for me, if I go from left to right, what might, and I'll do this in red when I get to it, what might the name sign stuck out front tell me as a transformation? Reflection through the x-axis. Now write that out for me. Reflect through the x-axis. Now, we're going inside the square root. Can anyone in this wise class tell me what might be advisable to do with that inside part of that square root before I ask you more about transformations?
They reflect through y.
There will be a reflection to the y. There will be. Guaranteed. Who said that? There will be. Guaranteed. But I think something needs to be clarified or cleaned up inside there, algebraically, before you consider the transformations. Inside. What's wrong with it? What does that inside look like it's screaming for you to do? You go back to the middle school, and you saw this in middle school. Just that. What do you think that middle school kid would probably think to do? No, that middle school. What would the middle school kid do? They'd probably say, and the teacher may say do this. Now, what's that middle school kid going to do? To negative 4x subtract 8, and the teacher stand up front with a smile on his or her face and send factor. What's the student going to do? You want to factor out negative 4. If I do, please tell me what's left inside here. X plus 2. You may have to factor inside there to make it look nice and rewrite this as, let me put it in, since I'm going to do some of this right here. I'm going to put it right here. Negative 4 x plus 2. Let me block that off so you guys can see it. That's the inside part, middle school, rewritten. Oh, this is going to be interesting. This is going to be interesting. Now, let's go from left to right. You guys have already told me, I'm going to do it in red when I get to it. This part says reflect through the x-axis. Now I heard a student say, Professor, also I see a negative sign for sure now. Right here. That says, what's going to happen here? Oh, well, I've got to find another marker here. What's going to happen here is, and another marker, is. Does this indicate to me right here, we're going to reflect through the y-axis?
Yep.
Okay, so reflect through the y-axis. So if the negative sign's inside, you reflect through the y-axis. If it's outside, you reflect through the x-axis. Well, we've got some reflections going on. As if that's not enough, now I'm looking at the problem myself, I may have made it a little bit too tough on us. But we're going to do it. Let's see if I can find more colors here that may help me. I'm going to try breathe. Now, since I have it in factored form, can anyone tell me, you got to write the words out for me, what might this tell me to do when I get to the green? Okay, horizontal shift, which direction? Left. To the left, how many units? 2. You have to write that out for me. Horizontal shift. To the left. In this case, 2 spaces, 2 units. I give you partial credit for doing that. Now, as if that's not enough, I think I'm going to do it in a different color here for a reason. Was there a 4 in there? Oh, I'm here already. Look at this mess. Even myself, when I finally start graphing this, if I can keep it up with myself, it would be a miracle. 4 says what's going to happen? It's going to shrink the graph by a factor of 1/4. Shrink by a factor of 1/4. If I see that, I know I know what you're talking about. Oh my goodness, let me count. 1, 2, 3, 4 transformations already. Am I finished? No, and then I see on the end here, let's see if this color will hold it up for me. I see subtract 2 right here, which means what? A vertical shift down 2. You said, Professor, we'll be here for an hour doing this problem. Not necessarily. Not necessarily. Now, first, do you guys agree with the transformations, the names? What's going on? You get partial credit for showing that. You got, in fact, I'll have a blank on the test where you have to write it out for me. so I'll know what you're doing. So if you have different markers to bring in, colored pencils, that would help. Now, here I go. Bear with me. On the side here. See if I can get this to work. On the grid here. How you guys want to place some numbers here that I might need? More, I'll find them later. And we'll start this. Now you guys seated in class. I'm right on top of the board. So do watch carefully as I start my work. So Ramsey, you made a mistake there. Go back and we gotta change it. I got all the different colors in front of me. So I gotta be careful. Can anyone tell me if this were an exam problem on the exam on Wednesday, what are you gonna do first? But you get lots of partial credit here. Do it again. You need a paragraph. You're gonna do all these transformations on something. What graph are you going to transform? You're going to transform the parent graph. And it looks like I see a square root staring at me. So your parent graph is going to be a square root graph, which is a nice graph. I'll put it in black. That looks like this. And I'll label as I move along the best I can. That's the square root graph. Now, if this had up here absolute value of negative 4x minus 8, not square root, but absolute value, if it had, what would your parent graph then look like? A V-shaped graph. So make sure you use the correct parent graph. This one's a square root graph, and that's what you're doing the transformations on. Now, here we go. I may look a little rough when I started. I'm going to start from left to right. Red says for partial credit, reflect that graph through the x-axis. I'm looking at the plot points. You say, Professor, can I just do this to show it goes underneath? Of course you can. And I'm going to label this as that. That's one transformation done. Oh, hold on. Yes?
On the test, do we have to like label every point?
Oh, yes. Jeez. You guys want to leave us to go to UCLA and not do something? Here we go. The red one's done. You got some partial credit already. Now going into, I got to be careful, guys. I think I did this one in blue. It says now reflect that through the y-axis. You'll say, well, Professor, what does that mean? Well, you're going to pick up with the red and reflect it across the y-axis. Please tell me, well, it looks something like this if I reflect it across the y-axis. And point label, and he was asking me about labeling here. At this time, that blue graph represents that. It represents the red being reflected across the y-axis. Yes or no? You guys see that? Now it says, don't stop there. Now this is a little bit tougher. The 4 says you guys described to shrink the graph by a factor of 1/4. You're supposed to shrink this blue graph by a factor of 1/4. Anyone tell me, and I'm doing that in, I guess, purple. Anyone tell me what on earth would you, as a good, solid student, do to that, where am I? The blue graph? What are you going to do to the blue graph to show me that maybe it should shrink somewhat? And in fact, by a factor of 1/4. What could you do to sort of show me, may not look nice the way we're graphing this, that it has shrunk some? What might you do? By a factor of 1/4.
Move it closer to the x-axis.
It might move closer to the x-axis, thank you. She said, Professor Alexandra, you're saying this right here might now be up here closer, still in this direction here, but closer to the x-axis? Would you guys agree? And could you actually plot a few points on that blue graph? visually, just find a few points that you think are on that blue graph and do what to the coordinates to get that, to do that.
Multiply the y's by what?
Not the y.
Yeah,
You're gonna multiply what?
yeah.
The x. By what, 1/4? You're gonna multiply the x coordinate by 1/4. Now she's telling me, if you do that, that graph, professor's going to just move closer to the x-axis. You guys agree? That would save me then, now this is one in purple. Alexandra, please tell me, are you saying it might look more like that?
Yes.
Now that's the part, that's one that's a little bit difficult to do unless you're going to really plot some additional points. Do you think it might take that shape though?
But it should be the same height as the blue, right? Because we're just editing the x, not the y.
On which one now?
On the last one?
On this right here, you're telling me it should be closer down here?
No, the last one that you did, it has to be the same height as the other one because we only edited the x. The y's are still the same as the other ones.
Exactly, I got you, exactly. But tell me though, I exaggerate mine.
Oh, okay.
Would you still think it takes that shape though? Now, he's got a point there. He said, Professor, if you actually went through and multiplied the x coordinate by what, 1/4? The y coordinate stays the same on those. He said, if I try a few points, Professor, it may look something like that. But is that reasonable? Is that reasonable? That might be closer to the x-axis, as Alexander described for me. Woo! Now, are we finished? Geez, no. Now it says do what? In the green? Now take that graph in the purple, which was the hardest one so far, and shift it to the left 2 units. So if I take that graph and shift it 2 units to the left, guys, the purple graph, please tell me, am I to the left? Is it now going to be here? Yes or no? And not like this? Yes or no? Is that 2 to the left? Woo! By the way, it looks somewhat like the other graph, except it's been shifted over 2 to the left. I did that in green. And finally it says vertically shift that down 2, you'll be finished. If I vertically shift it down 2, I'm doing that in this color. Yes. And if I shift down 2, will this point right here on the green drop down to here? Yes or no? And will it now look something like that? Yes or no? Tell me. If I vertically shift down 2, would you accept this? Hang on now. And we'll take questions here. This point right here was dropped down 2, vertically shifted down 2, and it was going in that direction. That was my green graph. Is that roughly where it should be placed? The final graph. Is this, right here, look at this. Is this the final graph of this? The entire thing. If I was careful enough, trying my best to show, especially that 1/4 shrink graph, that's the only one that I think messed us up. Now though, I'm going to test it. I wish you could do a little test on this and see if it does look okay. Mr. Park, Sujin, does that look reasonable? Were you guys watching what as I did it? Because there's so many different colors going on, and this going on, that going on, this being flipped, and that being flipped and shifted, and we think, Professor, I'm not going to do this, but I can just erase all this, erase it, leave this, and tell UCLA this down here, it's just this. It's the graph of all this. But we did it in transformations. What do you think would be wise? I'm going to try this and see if it works. What do you think I might try here before I close it down? To see, is that last graph reasonable to represent all this mess? This is a picture of all this. That's not a picture of just a square root. It's not just a picture of the -2. It's a picture of all of it. What would you like to do here? For a little test, or a little check. Just something maybe on the side that you could try. Guys, I'm going to go back to the parent graph. We'll do this. Here's the parent graph. Let's take a point on the parent graph and take it through the transformations. and see where it lands. If it lands outside this color here, I have a problem. So now let's go back to the parent. This is like a little check here. Can anyone tell me, not a good check, but at least a little check here. Can anyone tell me on this basic square root graph function, something that would be nice to work with, a point that you know guaranteed to be on the graph of square root x? Go for it.
4, 2.
I love it. 4, 2. Love it. Square root 4 is 2. You could have tried 9, 3. 0, 0 been even easier, right? Now, I'm gonna go through those transformations with what she gave me. And if I see it's not the final point I finally get out here, after I go through all the transformations, if it's not in here somewhere, I'm in trouble. Okay, here we go. First, we said to do this. Can you tell me in the red, now since you have a point to work with, not the graph, we reflected it what, across the x-axis? What might you have to do to get that effect on a point?
Multiply y by -1.
Tell me again.
Multiply the values.
Multiply the y coordinate by negative to make it go under. So are you telling me now the point might look like this? I think I did this in red. 4, -2. I'm gonna take the point all the way through. Am I finished? No way. Then, look at this. We did, I think, the blue. Which says now reflect that point through the y-axis. What do you think you'd have to do to make it go across the y-axis in the blue? Multiply the x by negative. If I do, the x right now is 4. Are you telling me guys now it looks like this? -4, still -2. Yes or no? Okay, that takes care of the red, the blue. Oh boy, Ramsey. Here we go. Now the shrink might look a little bit better on the point. We said shrink it by a factor of what, 1/4? And to get the effect here, what would I do next to get the purple to work out for me to make that shrink happen?
Divide x by 4.
Divide, which one, the x by 4, or multiply the x by 1/4? And please tell me, will that turn into -1, still got -2? Yes or no? If I divide that by 4, or take 1/4 of it. That's the purple done. Now the green. Right now space here. Squeeze the green in right here. The green says to now horizontally shift it to the left 2. What would I do to this point for the green to show there's a horizontal shift to the left 2? Here's my x. What should I do? Subtract 2 from it? Make it go to the left? Now it becomes what? Please tell me. Is that -3? -2. Yes or no? Whew. One more transformation. I'm getting scared. One more transformation. I'm supposed to now pick up the green. I think we finally did this business. Vertically shift it down what? 2. And find that effect on the next color there. Shift it down 2, do what here to this one? Subtract 2 from the y coordinate. So -2 subtract 2, what's it, -4? So we end up with -3, -4. Oh, my goodness, my goodness, my goodness, my goodness. You start here. You end up here. First, is the graph reasonable then? If I plot -3 down 4, this is -2. If I got to a -3 and drop down 4, is it reasonable it may land on that yellow or orange graph? If I can move out -3 down 4? Yes or no? Is it reasonable? And also, is it reasonable, here we go. If I go back to the original function, this mess, here's the original function, and I ask you to find f of a -3. F of a -3, there's another way to check it. I'll have to find f of a -3 on that original function. If I crunch it out and I don't get -4, something's wrong. That's no way to check it. So let's try to find f of -3. Guys, watch. It's negative square root -4 times -3. That's the x. Subtract 8. Subtract 2. I'm getting scared. This gives me negative square root. Underneath there, I think, is what? 12 subtract 8? Is it positive 12? Subtract 8, which is what, 4? And I think this is what? Is that -2? Is square root of 4 2? -2, what is that? Is that -4? How cute. Is that cute? It's not going to be so cute when you try it on the exam Wednesday and it doesn't check. So I'll probably ask you to take a point and take it through for me, like I did this one, which makes a lot of sense here. You guys agree with all this business? Ooh. Now, these are all transformations. Now, I did not have this to happen. I gotta watch my time here. I'm getting carried away. Did my last graph intersect the x-axis? Would this last graph, no matter I say it's going to extend forever, do you think it'll ever touch the x-axis if there and have an x-intercept? No. Will it ever, I see what the graph looks like, will it ever go up and touch or go backwards and touch the y-axis? Never. So there is no x-intercept or a y-intercept. If it should, though, and some of these graphs will, your final graph will touch the x-axis, how would you find it? Suppose it had intersected the x-axis. How would you find the precise x-intercept if, let's say, I don't want to mess my nice graph up here. That's a pretty good job of that graph. Don't you guys think of that? Is it nice? Wasn't this nice here? Oh, it's cute. It sure checks. Oh, but suppose your last graph looked like this. And I'm not going to do one like this today. Suppose it looked like this. You said, Professor, my graph looked like that. Yeah, and this one would, if it had looked like that, as it has an x-intercept. And suppose on the test I say, now yours does cross the x-axis, mine in class did not. Tell me precisely where is that x-intercept. What are you going to do? You're going to set y equal to 0, or your function equal to 0, this, and good luck, and try to solve. Frax. And find the x-intercept. Yes? No? Okay. Now, I'm leaving this, but, Alexander, you just mentioned it to me. If there was an x-intercept on this one, which I Professor, there's not an x-intercept on this one, you would do this, as she just told me. She says, Professor, go back and write this like this. That's where you find an x-intercept. And now solve it. Okay, how can I solve it? Move the 2 over. And just try to solve for x. And then do what? Maybe, I don't think I'd square yet. What might you do first? Maybe multiply by negative or divide by negative. And you would have this. Now, could you, as a clever, strong math student, stop right there and say, that's impossible? You're never going to jump in and square both sides, are you? What tells you right now, no need to go any further. Why? Can a square root ever be equal to a negative value? No. So you stop right here and say, now I see why that yellow there, orange, right here, does not touch the x-axis. But sometimes they do. Guys, any concerns here? I think it's looking good. Let's see what I do here. That's something else here to do with you guys. Oh, yes. Here we go. Now, what a good lead up here. Let me see how much time I have here. I have, oh, there's enough time here. Now, Alexandra, I'm getting your question you had at 4 o'clock. I'm gonna lead right into it. Guys, this is all gonna be erased. You're saying, Professor, will I have something like this on the test Wednesday? You will. Maybe not as many transformations as I had here. I had, if I count them, what is that? 1, 2, 3, 4. I had 5 transformations. Along with the parent graph. They've got crowded up here. You may have 3, because you may not have time to do all 5. Now, with that said, before we get to the break, let's see why I may have in my planning had preferred to do something like that first. Leave that graph there. Let's call this part 3, I think. I'm gonna give you a function. And I've labeled this function as, here goes. Nice, nice, nice. That. I want you to sketch this using transformations. So from top here, sketch. What a beautiful lead in to where I need to go. Guys, we just did one over here. This is way shorter. So we'll go to the grid again. Now, you saw what I did over there? Okay, anyone first tell me how many transformations on this nice problem here before the break comes up, how many transformations are involved? 2. Not 5. Only 2. But I need a parent graph. Now, can someone tell me what on earth is the parent graph on this one? It's a graph of an x squared. This is not like a quadratic. And a quadratic should have a graph of a parabola. Now, if you just quickly say, Professor, a parabola opening up, I'll take, and I'll label this so I can see it. I know it extends forever. I'll go ahead and do that. Label my x, label my y, there it goes, nice. There's my parent graph. 2 transformations. First transformation is this, which says there's going to be a horizontal shift. In this case, what? To the right? 3 units. So just show me roughly. With that graph, it's going to be shifted over 3 to the right. And you have that much going on the graph for you. And it says, Professor, it's going to look something like this. Yes, it's going to look something like this. And we label this as y is equal to, this represents x subtract 3 squared. Guys agree? What's my last transformation? Vertically shift down 4. If you ever watch something, watch this. We'll lead you into something. Guys, here we go. Shift down 4, vertical shift down. And if I do that, let's do that in this color here. Please tell me this point now, I guess it's down here. We're going to label this point. Looks like it's out 3, down 4. Guys, is that true? Now what's it going to look like? It's going to look like this graph here, the green one, except now it's been shifted down 4. Is it going to look something like this? About your sketch. Is it? Now, will this one cross the x-axis? Will it cross the y-axis? I'm looking back on this one. Might it even cross the y? It depends on how wide the thing opens up. So this one may have x and y intercepts. This one over here did not. So I'm going to find the x and y intercepts right now, place those before I actually get the last graph. So guys, before I do it, on the side here, x-intercepts. And I was told earlier to find it, set f of x, y equal to 0. And professor, you have this. Solve. So we'll try to find the x-intercepts. A good way to do this, you could expand this out, but I think a good way is just move the 4 over. Do a square root on both sides. By the way, guys, if I do a square root here, square root here, I'm going to end up with, I'm going to write this as plus minus 2, only for the reason I'm expecting 2 answers. And then x subtract 3 here. Now please, please, don't go into another class and say, Ramsey showed me that square root 4 is equal to this. It looks like that's what Ramsey was showing you. Guys, what is square root 4 from elementary school? 2. It's not plus or minus. Why did I put plus minus as a prefix in front? Is this a quadratic? Am I supposed to get 2 answers? That's the only reason I put that plus minus in front, to ensure I get 2 answers. Move the 3 over. And you're going to end up with, erase this right here. Looks like it's going to be 3 plus minus 2 is equal to x. We write those as ordered pairs. 1 is going to be 5, 0. 3 plus 2. 3 subtract 2, 1, 0. Guys, we place those right now. This is in purple. If all that's correct, if anybody sees a mistake, please let me know before I finish this up. Put down here 4, 5. That's an x-intercept. And also we had a 1 as an x-intercept there. That's true? Now the y-intercept. There might be one. On the y-intercept, you go on the side here. Please tell me if on the exam you have to find the x and y-intercepts. Who knows? What's a good way to find the y-intercept? Set the x equal to 0, which merely says find f of 0. If I go back to my function, replace x by 0, you're going to end up with, looks like a 5. Please tell me, did I do the arithmetic correctly? Is it 5? Is it 9 subtract 4? Help me out. Is it 9 subtract 4? Is it 9 subtract 4?
Yeah.
Okay. So it's 0, 5. There is 1. We'll write it as an ordered pair. So on the y-axis, you can do it right now so I can get ready for it. On the y-axis, y-intercept, we discover there is 1, 5. Right there. Now surely to goodness, we found all my points. We've got a point here, point here, point here. A little bit bigger. And down here. If I connect, please tell me, even on this rough sketch, this color here, it is going to look something like that. And that's my final graph. Got 5 minutes. Now what do you think I'm going to ask you to find here? You've already graphed it for me through transformations. What do you think on the exam I would have as part A, part B, part C? What would I be asking? I want domain and range. Billy, here we go. The domain. This darn color's almost got on me. Domain would be, the way the graph looks, as I see it goes on forever here. What would you say, guys? All real numbers. So negative infinity, and this graph, sorry, this color, it's going out on me. Range, the up and down, how far down does it drop? -4. And that goes up forever, so bracket -4 through infinity. Whoa, yes or no?
Yes.
We've got the x-intercepts, y-intercepts, the domain, the range. You say, Professor, what on earth else could you ask me to do on this graph? Let me throw it out there in my last 5 minutes. Does anyone see anything else I might ask you? I got the domain and the range out of the way. Tell me again.
The minimum or maximum?
Thank you. The minimum or maximum value on this graph. Please tell me, is it a maximum on this graph?
No.
No, in fact, it's an absolute, what? Minimum. And also local. So right here, I'm gonna call it local. Minimum value. And guys, I just want the y value as I did on my first test. And that y value is -4. You said, Professor, could I also call this the absolute? Well, of course you could. That's the absolute minimum value. All this math connects. -4. Anything else I could ask you? Yes? Can anyone tell me in interval notation, when is that happening? When is f of x less than 0?
From 1 to 5.
Okay, he's correct. And in fact, if I have the graph staring at me, what are you looking at on the graph? You don't have to go to this. Look at this now. You could say, Professor, you mean for me to go back and consider this function, right here. Now watch carefully. I'm about to break here. That's exactly what I'm asking. And some students say, wait, Professor, can I not expand this out and call it x squared subtract 6x, I think it's plus 5. We said earlier. Could I actually do that? Could I think of it like that if I wish as a student? And then guess what some students would do to answer this question? They would use sign analysis. They'd find the critical numbers and use sign analysis. Now, those that you have the graph staring at you, is there any need for sign analysis? You could use it. No, he's telling me, wait, Professor, in essence, you're telling me since I have the graph, what is that graph below the x-axis? And he says it's from 1 out to 5. Is it true? Is that what's below? Now, would you get the same answers if you did it this way and use sign analysis? Like you did on the first test, you get the same answer. So this will be answered as 1 out to 5. Less than 0. Alexander, what was that question?
I was just gonna ask if that's how we're supposed to write it, or like 1, 0 to 5.
Beautiful, beautiful. If you say, Professor, I put in interval notation. You're saying, Professor, could I write like this? X falls between 1 and 5. Same thing. Same thing. Oh, I have tons of things I could ask you. Now, the last thing, then we'll take a break. You're staring at it. That's the graph. Anyone tell me, before we go to break, or maybe I should have the student come up. Can someone tell me what on earth would this look like? On that graph. Absolute value of the function. Would someone like to volunteer to come up? I've used all these different colors. I see the purple graph. You guys accepted the purple graph. Maybe someone can come up and put in this color here and show me what this purple graph, when I sketch the absolute value of it, what does the absolute value of it as a graph look like? And it's going to be very easy when you see what happens here. Come on up. And make it a little bit darker so we see it clearly. Sketch. Let's go out on you too. That's it, darker we can get. Let me see. You got it. Do something like this, I think. What's it? Yeah, down here and back up here. Guys, can you see that roughly? Oh, boy. We're saying it looks something like this. Oh, these markers are dead. Goodness. It's gonna look something like that. Yes or no? Now, one way to check, absolute value always comes out to be what? Positive. Is his graph all above the x-axis? In positive territory? It should be. In fact, these two pieces here, I think, this edge here and this edge here, they were there to begin with, weren't they? So he didn't have to change that, but he had to flip this part up there, this part down here, above the x-axis, to make it positive. Right to the back. Wow, wow, wow. Making sense? Now, I know it's past time, you still get your 10 minutes. I'm not gonna do anything else, I'll ask a question, and we'll break. What was my lowest point on this graph? What is the minimum value on this graph? The graph says -4. We're not gonna do this today. Yusujin, if I start with her and went all the way through, picked up all, let's say I have 30 students tonight, and asked every one of my 30 students to use a different x value, choose a different x, and plug it in, replace it, oh, here it is, replace it here, and tell me what you get. And so it depends on what the x value is. So Yusujin said, Professor, I guess I'm gonna put a one in there. Well, 1 subtract 3 is -2, square 4, 4 subtract 4 is 0, she gets a 0 for an answer. Go to my next student, I'll say, now try a different, don't try the same x value she did, try a different x value. Any x value you wish. That's my domain. The domain was this. And then they say, well, I'm gonna try 5, Professor. Go for it. You'll get an answer. Then I go through all 30 with 30 different x values put in there. What am I assured of, and you are assured of, with those 30 answers coming out based on what we have here?
Lowest point.
Tell me again.
It's the lowest point.
Yeah, something else, a little bit better.
The vertex?
Yeah, I'm talking about that, short, something else right now. What am I assured of as an instructor? Okay, let me phrase it like this before we take a break. Suppose I pick up my 30 answers, and a student has further answer, they put an x value in for me, of their choice. And they say, Professor, on the paper, I look at it and I say, oh, you got a -10 for an answer. How will I recognize quickly? You're wrong. You can get a -10. What's the lowest this thing goes down to? -4. So all 30 answers when I check them had better have an answer what? Bigger than -4. If you get something less than -4, I know you're wrong. So if you got a -10, you did the arithmetic wrong. And I'll see you during the summer. My goodness, no, the lowest you can get for a value is -4, no matter what you replace x by. Guys, take your well-deserved 10-minute break, and I'll see you in 10